quick check. What do these curly arrows really show? Here's the rule most beginners miss. Arrows show electron pairs moving, not atoms, and they never start at a positive charge. So, how do you read and draw them the right way? In this video, you'll learn how to read and draw electron-pushing arrows, how nucleophiles and electrophiles connect, why charge is conserved, and how the octet rule guides what arrows are allowed. Let's start with the one idea that powers everything. Curved arrows track electron pair motion in polar reactions. They start at electron density, a lone pair, a negative charge, or a bond, and end at an atom or the bonding region that will receive those electrons. Now, let's label the two players sharing those electrons. Think nucleophile to electrophile, from electron-rich to electron-poor. The nucleophile donates a pair, the electrophile accepts it. So the arrows always go from nucleophile to electrophile. Let's make that concrete with quick do's and don'ts. Do start arrows only at places that contain electrons. Do land them on an atom to make a bond or lone pair, or in the bonding region to form a bond. Don't start at a positive charge and don't point to nowhere. For example, hydroxide attacks a carbocation. Push from oxygen's lone pair to carbon, form a carbon-oxygen bond, and the charge on oxygen neutralizes. And here's the classic mistake to avoid. Drawing the arrow from the positive center is wrong. There are no electrons there to move. Always draw from electrons, toward electron-poor sites. Let's lock the rule set in with a mini-check. Arrows start at electrons, end at atoms or bonds, and flow nucleophile to electrophile. That's your baseline. Want to turn those milestones into mastery? Tap the link to access the practice test, flashcards, and study guide, then jump right back into the video. Lock in what you learned and keep going. Next, keep an eye on charges as you draw. Track charges step by step. Negative nucleophile plus neutral electrophile. Donation often neutralizes the nucleophile. Neutral nucleophile with a positive electrophile. After donating a pair, the nucleophile can become positive. Negative nucleophile with a positive electrophile. Transfer of an electron pair neutralizes both partners. If both are neutral, the donor can become positive after donating a lone pair, and a negative site appears elsewhere.
Charge isn't the only constraint. Octets matter too. The octet rule, especially for second-row elements like carbon, nitrogen, oxygen, fluorine, limits bonding. If a carbon already has 4 bonds, adding a new bond must be paired with another bond leaving or electrons shifting, so nobody exceeds an octet.
Let's practice with an acid-base step. Push the base's lone pair to hydrogen, and push the oxygen-hydrogen bond back to oxygen. You form BH+, a protonated base and water. Note that the total charge before and after is the same. Now apply the same logic to a carbonyl. Aim the arrow at carbon. That's the electrophile. Push the pi electrons up to oxygen to keep octets satisfied. After workup, the alkoxide becomes an alcohol. Let's wrap it all up in one quick note. Arrows start at electrons and point nucleophile to electrophile. Land on an atom or bond. Keep charge conserved and respect the octet. If a new bond forms at saturated carbon, another bond must leave or electrons must shift.
Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet, content made just for you.